Seventh grade, here's your lesson for Monday, February 25th. Holy cow, February, it's almost over. February 25th, 2019. We're going to start today on page 122. So in your books, let's go ahead and go to page 122. A lot of stuff we're going to do today is going to deal with these two things. How do clouds form? And then the other thing we're going to deal with is what are the three main types of clouds that we have? So those are the things we're going to kind of talk about as we continue with our weather section. So let's figure out the first one right now. How do clouds form? Okay, so clouds form when water vapor in the air. So all this water vapor, the humidity that we have, when it comes back into the liquid form, those are basically clouds. So when we see clouds in the air, that's basically what water is. Water that has came from that gas form, and then it condenses back into liquid water. Think about that humidifier I had going the other day. If you were to put your hand on it or a metal surface, it would start collecting there and then eventually become water droplets again, forming down. Okay, so this is a process called condensation. Okay, so for that to happen, we need two things to happen. First off, the air's got to be cool enough for it to do that. And the second thing is the presence of those particles in the air. If we don't have any water vapor, then we're not going to have any clouds. If it stays too warm, it's going to keep hot. It's going to keep that same type of water vapor we have. But if it starts to cool, then it starts to come back down to being liquid. Now remember, we're not talking about where we're living at around here on Earth. We're talking about clouds up here above the surface. But sometimes we can have clouds on the surface where we live. Okay, so that's how clouds form, is when they're going to condense to form liquid water. So that's on page 122. We're now going to go to 123. So how we get it to cool. So the temperature at which condensation begins is called the dew point. Okay, sometimes with a dew point, when it can condense, it's going to be around that 32 degrees was where it's going to start to freeze, or a little bit higher. So it's going to depend on a lot of different things, mostly the pressure and then where it's at. Okay, if the dew point is above freezing, then the water droplets will form. If the dew point is below freezing, we might go directly into ice crystals. Okay, so if we were to go to weather.com, now remember I'm making this the night before. And we're going to go to Ord, Nebraska. And we're going to see at what point does it start to go back and condense. Okay, so when I look at the temperature right now, and it's at 1 degrees. Okay, look, I have 72% of my air is filled with water vapor. Now the dew point on here is -6. So right now we have all this water vapor in the air. If we want to become liquid water again, such as if you want snow, if you want rain, it's going to have to reach -6 degrees in order for it to do so. Okay? It's going to change. If I were to look at it today, the day that you guys are looking at it, it might be a little bit higher temperature depending on where we're at in the day. Okay, so the dew point is just the temperature that's going to condense, and it can change based upon what our weather conditions are doing. A lot of times it happens if we have a surface for it to condense on, just makes it easier for it to do so. Okay, so we're going to fill in this blank, and you're going to have questions to fill it off. You can fill it in your book, and you can fill it on the questions too. So warm, moist air from the surface rises. Okay, as it rises, it cools. Okay, it's going to be cooler up here. At a certain height, it cools to the dew point. Now, that's where the dew point is the temperature at which condensation begins, and that's why right at this point we start to get clouds being formed. So water vapor condenses on tiny particles in the air, forming a cloud. Okay, so our three types of clouds that we have are based upon their shape and then we're going to base upon them on how high they are up in the air. Okay, so one of our types of clouds are called cirrus. Our cirrus types of clouds. Another type is called cumulus, and then our last one is stratus. Okay, so what are the three main types? Now, when I look at cirrus clouds are usually higher in our atmosphere, and there's not much shape to them. They don't look very thick. They don't look very, they're more very fine. They're kind of like a thin strands of hair. Those are going to be cirrus clouds. So when we look at some other ones, if we look at our cumulus clouds, let's find our cumulus. Cumulus clouds are one you're probably most familiar with because there's more fluffy ones. And they're a little bit more thicker. And then if we can find our stratus, I think stratus is on our next page. And our stratus clouds are going to be a little bit lower in our atmosphere, and they're usually a little bit darker, and they form like layers. So we kind of have very thin with our cirrus, more thicker with our cumulus, and then our stratus are more just a flat layer. They're not thick, but they're not thin. They're just a layer of them, where our cumulus are more thicker. Now, when we talk about their heights, if we have something like our altocumulus or our altostratus, here's what an altocumulus would look. That just means it's higher than our regular cumulus clouds. Same with our altostratus. It's a little bit higher in our atmosphere and a little bit more layers. Our cirrocumulus, still again, a little bit more up here, a little more fluffy, not so much like these thin strands that we're going to have. And then one of them that's not here is our fog. Now, fog, if condensation happens, so if we go back to page 123, if this happens down here, it's cool enough down here, it doesn't have to rise, that's where we'll start getting fog to be formed on our surface. Okay? So go ahead and let's label this. What are the three main types of clouds? Go ahead and list them there, please. All right, then we'll make our way to page 126. On page 126, we're now on precipitation. With precipitation, one thing we want to know about are what are the common types of precipitation, and then we'll talk about what are the causes and effects of floods and droughts that we may have. Okay, so what I'd like you to do, I'd like you to read a little bit on this cloud seeding, on what cloud seeding is, and then go ahead and answer questions 1 and 2 on your books. Go ahead and pause the video, and by the time you get done, you go ahead and push play. Okay, so cloud seeding is a very unique process, and basically what they do is they send up these silver iodine crystals, because you remember, in order to condense on something, in order for water to turn, or humidity, that water vapor to turn back into water, it makes it easier if there's something there. Think about when you take a shower in the morning, you see the water droplets on the mirror. Or when you get that steam, it's always going to form on a metal substance. So we're trying to send up these iodine crystals up into the atmosphere. That way, once we get it up there, those water droplets will form on that silver iodine, causing it to rain a little bit more. Okay, so it's a great process, and it seems like a great idea. And it says here several states are using it, such as Wyoming, Utah, to get as much rain as they needed. So, and it can increase it up to about 10%. So why don't we use it more is the question. Why isn't this a process where, oh my gosh, we need a drought, or we're in a drought, our farmers need rain, that we need to use it on? And the reason is because basically it's so expensive. Cost of cloud seeding. So the reason it's kind of called cloud seeding is because we're seeding clouds. We're trying to make clouds to make it rain. A cloud seeding program costs up to $27 to $244 per acre in a high cost scenario. So quite a bit. Okay, so it's a pretty expensive process to do so. I mean, it's $214 per acre foot, so that's a lot of money, but it might be something that we have to look into or into the future if we start getting more droughts in places like California, which continues to have droughts, and they get a lot of fires too. That might be something that they have to look into. Okay, so let's look at our first question. What are the common types of precipitation? Okay, so some of these you might be aware of. Some of you probably heard of them before. So we're going to go through them and review what can cause certain types. Okay, so precipitation is going to be any type of water that falls from clouds and comes back to the surface. Okay, so that could be anything such as rain, sleet, freezing rain, snow, and hail. Any type of precipitation that comes back to us in rain or any type of liquid form. Okay, our main type of precipitation is rain. We can have different types of rain droplets depending on the size. Sometimes you get very thin ones, our mist droplets, our cloud droplets, our drizzle, and then you'll get our raindrops, which can range from about 0.5 milliliters to about 5 millimeters, so a little bit more. Okay, so how do we collect rain? One of the things you always hear people talk about is how much rain did you get? Well, you get a rain gauge out, which is basically like this, and you collect it in the rain, and then you find out how much you get. Did you get an inch? Did you get a half of an inch? Did you get a tenth of an inch? That's just something that a lot of people utilize to discuss how much rain did a certain region get is using a rain gauge. I'm sure a lot of you have one, or your grandparents have one, or somebody has one that talks about how much rain they would get. Okay, our next type we can have is freezing rain. Now, with freezing rain, what will happen is rain comes down, and then it might collect on something, such as here it's collecting on this fruit here, and it's starting to freeze because it's so cold. So maybe up in the atmosphere up here, it's warm enough for it to have rain, but it's colder down here, so it gets down here, then it eventually cools and becomes freezing rain. We've had some freezing rain lately in about the past month, where it comes down, lands on the cement, and then it freezes there. You know, it might come down as rain, where it is, and then it reaches the ground. It's cold enough to freeze. Snow, we've been pretty familiar with that as well too. So snow, that's happening up more in the atmosphere, and instead of turning to rain, it turns to ice crystals. So it's not rain droplets, it's more of a freezing of that rain up here and then falling down this way. Okay, one of our other types we have is sleet. What sleet does is it comes through a region and it falls as rain. As it falls through a layer that's below 0 degrees Celsius or below 32 degrees Fahrenheit, it'll freeze on its way down. So the difference between this one and freezing rain is freezing rain comes down and then lands on a surface. Sleet comes down as rain, and as it's falling, it turns into ice. And then our last one, hail, something we don't want to deal with, is basically the freezing of rain up here in the clouds. Okay, so what happens is they go through these updrafts, and we're going to do a lab on this hopefully on Friday, where we go up, we collect water here, and they have these updrafts that bring it up where it starts to cool, and as this rain cools, it becomes heavier, it becomes that ice, and then it starts to drop down and get ready to fall, and it'll get pushed up by an updraft again. But as it does, it'll collect more water right here, and it goes up, and then it'll come up here and freeze, and it'll drop down again. Eventually it becomes too much where it can't hang on, and then hail will start to fall. Okay, so as we're looking at this, with our rain, the air temperature, we're going to circle this, our air temperature is going to be above 0 degrees Celsius. Okay, so we're getting liquid water. Okay, our ground temperature is also going to be above 0 degrees Celsius. Okay, with freezing rain, it's going to form as rain, so it's going to form as liquid above, but on the surface, it's going to be at or below. Okay, for sleet, same thing. It starts off as rain, so we're going to circle this one, but on its way down, it's going to go through layers that are below 0 degrees Celsius. So that's the one we're going to have. Snow is going to be different. At snow, what we're going to have is it's going to form at or below 0 degrees Celsius, because that's where we start getting ice crystals. So that's where it's going to form up top. Now, the ground temperature, it could be either one of these. Okay, it could be above or it could be below. If it's above, when it hits the ground, it's probably going to melt. When it's below, it's going to come down. That's what we'll get when we get a lot more snow, because it'll collect more. Okay, hail is usually going to be this one. It's going to be at or below. That's why it freezes. But it's the same thing here. Normally, it's going to be above 0 degrees when it comes down. But we could have hail during freezing temperatures too, but it's probably not as likely to happen. All right, so let's finish up with precipitation, and then we're going to go over some questions on your worksheets that you may have. So first off, I'm sure you know what a flood is. A flood is when we get too much water in a region. It can happen a lot. Hurricanes, it happens a lot with. If it starts to rain a lot, or if we get a lot of snow and it starts to melt right away, we get these things called flash floods, which happen very rapidly because we can't drain the water fast enough. We can't get rid of it fast enough. So it may overflow, causing places to get washed away, causing things to get moved out. Okay, so the opposite of flood is a drought. So when we talked about cloud seeding and how we might be able to get that to be more effective, sometimes we get a drought. Our farmers need that rain. So this might be a time to utilize that crowd seeding if economically feasible. Okay. Droughts are usually caused by dry weather systems remaining in one place for weeks or months and a long time. That's the key. It's going to be for a long periods of time. Here it talks about droughts can cause crop failure. Streams and ponds can dry up. People and animals can suffer. I know in some places where they have droughts, they won't let them water their lawns anymore because they need the water for other things than to keep your grass nice and green during that time. So sometimes they'll put a ban on how much water you can use. Some places, I believe it's in Iowa, are now putting a gauge on your irrigation for crops to find out how much water you're utilizing. That way people aren't just out there constantly running water while other people don't get to use any. And so they're trying to make it more of a better resource for people to utilize. Okay. I'm going to want to go over some questions on your worksheet that you possibly may have. All right, looks like I opened up a few of these. So let me get this a little bit bigger so we can see it, because there are always some questions usually on here. First question says, although William Wilson Bentley never found two snow crystals that were exactly the same, he did learn that snow crystals always have the same basic shape. So we're doing the shape out of these. It's asking, if I were to draw a line and connect these here, what is the basic type of shape that they're forming? Even though they're not the same, okay, they all have that shape where they go 1, 2, 3, 4, 5, a six-sided object. If you don't know what six-sided object is, Google it. Okay, number 2, most people rarely see snow crystals that look like the ones in the figure. This is because the snowflakes that reach the ground actually are composed of bits and pieces of many different snow crystals clumped together. The biggest snowflakes, which may be as much as several centimeters in diameter, are also made of pieces of hundreds of individual snow crystals. How do you think snowflakes form from individual snow crystals? So go back to how it forms on page 130 and how snow forms, and that'll give you your answer for how those snow crystals are created. All right, and then the other question you may have once you get to this worksheet is dealing with different types of fronts. So in this question, number 1 says, what is the difference between the occluded front shown in figure A and figure B? Okay, so what is basically the difference between these two? There's lots of different stuff here. There's lots of different things. You got to look at your warm air, your warm front, your cold front, and then your cold air and your colder air on both sides. Okay. In figure 2, it said which air mass is the densest, or figure A, which air mass is the densest. The one that's in the densest is going to be at the bottom. The one that's the least dense is going to be at the very top. That's what densest means. And work your way through the rest. If you have questions, feel free to ask. Otherwise, once you get done with this, you can work on that worksheet, try to get that finished. We'll try to have it all finished by Wednesday of this week so we can get started on our lab. And we're probably going to try to have our test next week by the time we leave for our break, or for our spring break that we have coming up. When you're done with that, I'll try to have a review on Classroom for you to utilize to play. That way you can start getting prepared for your test. That way when it comes, we'll be all ready for it to go. Have a great day.